Then there were tabbing problems, which once you get into Python, you flat out have to fix, But you can type in anything you want in pseudocode and nobody tells you about it except me. Everything after a while needs to be indented. I should have put a start here. Everything after the start needs to be indented. Some people didn't indent after the while. So they had while, repeat, equals, whatever. They had, C is equal to input, C, whatever, The people who didn't tab everything under the while tended to get the if statements right. And the people who tabbed after the while didn't always get the if statements right. If you do this, if whatever, then the output, whatever, needs to be tabbed, right? So you got to do that. Else if whatever, output. Okay, so if it looked like this, that's not right. If that was dedented, that's not right. I tried to point them out. Sometimes I'd correct it and take a snapshot of the correction and send it back to you. If you didn't get full credit for it, feel free to revise and re-upload. Otherwise, really good, y'all. Last thing I really thought, as I put in a comment, that I had given specifications for what I'd like to see at the top of our submissions. And I don't see it posted in the news. I don't know what happened. I swear I remember talking about it, but maybe I dreamt it. I dream about Python and stuff like that a lot. I don't know about y'all. So please put something like this up at the top. This is for a program, your name, the date, a description of what it is. If it's pseudocode, you don't have to start everything with a pound sign. It doesn't hurt. If it's a flowchart, don't go nuts like that, but at least put your name and the date and homework 3 or something like that. Just make your work your own. Sign your work. You're an artist. So we've been sort of bouncing back and forth as we plowed through how to think like a computer scientist, as I covered something in an in-class assignment and we then hit the lecture about it. I want to go ahead and work our way through the fruitful functions. Chapter, which is chapter 6. Python comes with some built-in functions like max or ABS. We can illustrate those with the shell. They're built in. You don't even need to write a program to take advantage of them. What is the ABS of negative 10? The absolute value of negative 10 is 10. What is the ABS of positive 10? 10. That kind of thing. Input is also a built-in function. Lets you type in something and then it returns it. I didn't type in anything. So it says, what is your age? I type something, it returns it. When you're doing it in the shell, it prints out what was returned. So if I did float of 45, a string containing 45, it's going to print that out because that was returned. In the program, input or float or things like that don't print, but they do return values. That's why we can do stuff like this. Input, what is your age? And then get that. Age is, whoops, I forgot to store the value that was returned. Age is equal to input, and then age is equal to float age. And then we could do something with it, if age or print age or whatever. It's not going to do the same things that it was doing in the shell because each one of these things was actually printing its value when I called it. That doesn't happen when you run it as a program rather than in the shell. I'm going kind of fast because I'm not really expecting y'all to type this stuff in yet. But we will get to that real soon. Okay, so I ran it. It says, what is your age? I type in something. I type in something incorrect and it blows up. Let's try that again. 45. and then it prints it back out. So, built-in functions. Most of the built-in functions are what are known as fruitful functions, which return values. They bear fruit. I don't know why they called it that. Then there are void functions. Void functions do not return values. I think that print is probably a void value, because why would you do this? A is equal to print. Why would you want to store some result from printing out? Let's see if it actually, we can just do it in the shell. No, let's do it here. It's probably going to print the word none. None. Void functions in this language return a special value called none. So examples of which are fruitful functions: ABS for absolute value, input, int, float. One book I used to teach from called them BIF for built-in function. We're not going to call them BIF. And then void functions do not return values because sometimes you don't need to, like our flower function. When we were drawing a flower on the screen, what was there to return? It's not like we were calculating anything. We were just drawing. There was no reason to return anything. Offhand, I'm not coming up with any other examples of void functions that are built in other than print. Alrighty, so let's play with functions. Let's define a function, DEF. We're going to call this one Joan Jett. So we always use the DEF keyword followed by a name, followed by parentheses and a colon. And what does a Joan Jett function do when we call her? She sings, "I love rock and roll." Then she sings, "Put another dime in the," help me out here, "jukebox, baby." Yeah, alrighty. There we go. That's enough. We can stick an optional return statement at the end. I like seeing returns at the end of my functions, but you don't have to put them there unless they are fruitful functions. This is a void function. She goes up there, she sings, but she doesn't send us anything back. Her performance is enough. Let's define another one. Huey Lewis. We're in an early 80s kind of mood. Print. The heart of rock and roll, print, is still beating. Then we return. Again, we return nothing, or as it calls it, none, because it is a void function. We could probably even put the word none right there in the code, but that'd be going way overboard for something that doesn't have to be there in the first place. All right, now we're going to have a concert. Joan Jett comes up. Then Huey Lewis comes up. And then Joan Jett comes back for the encore. All right, what am I going to call this one? Rock and roll. So I run it. It says, "I love rock and roll. Put another dime in the jukebox, baby." She's done with her show. The heart of rock and roll is still beating. You know, if I paid money for this show, I'd be kind of disappointed. Then she comes back and says, "I love rock and roll. Put another dime in the jukebox, baby," and we're done. So hopefully you see the way these are laid out. What's happening? The DEFs themselves don't do anything. If I didn't have this stuff down here at the bottom, I'm going to cut it momentarily to prove the point. If I didn't have those three statements down at the bottom, then when I tried to run it, it wouldn't do anything. Why? Because it's defining stuff, but nothing's calling them. It's like you build a blueprint, but you don't actually give it to a builder to make. You prepare a menu, but you don't, actually sit down and follow the menu. Defining functions doesn't do a bit of good if they're not actually called. That's why we called them down here at the bottom. So those are void functions. They didn't need to return anything. More serious examples of a void function is just, some kind of output. Draw a square, relocate your cursor, draw a circle, draw a flower, output, the payroll results, that kind of thing. That's the kind of thing where you tell somebody to go do something and then they run off and do it, and you just trust them to do it, They're not bringing you a report back of any kind. A fruitful function is one that returns a value. That's kind of like input or calculation. Let's define another function. Define favorite artist. Okay, that's a bit long. Fave singer. Singer equals input. Who is your favorite singer? Now we've asked them that, so we may as well return it. Return what they typed. This is a fruitful function. Let's make this fave singer function a little bit more sophisticated. We're going to give them a menu of choices. So we should have used a print statement rather than putting our printing inside the input statement. Let's make that change. Sorry to change gears on you. Cut that stuff out of your input statement, and we're going to add some prints like this. Who is your favorite singer? And then we're going to give them some choices. JJ for Joan, Jet, HL for Huey. All of a sudden I forgot how to spell his name. Lewis. And then they type in whichever they like. Now down here, we're not going to just summon them and make them do concerts one after the other. Instead, we're going to check the result. Only our favorite singer is going to sing. So, I haven't called the fave singer function yet. I was about to make a mistake. I was about to do something like if singer equals JJ, but I couldn't do that. I can't do this if singer is equal to JJ. Don't type this. This is bad code. Why? Because I never called the fave singer function. So that code just sits there being unused. It's latent, it's lurking, waiting for us to use it. So let's do this. Singer is equal to fave singer. All right, now that we know who our favorite singer is because they typed it in, we can do an if statement on it. If singer equals JJ, colon, we will summon, we will invoke, all these terms sound vaguely demonic. I'm going to invoke Joan Jett. There we go. Elif, colon, elif singer is equal to Huey Lewis, colon, Huey Lewis takes the stage. And then anytime you have if, elif, it's a good idea to tack on one final else, even if it doesn't seem strictly necessary, just to tell them that they did not type in a correct value. We'll print, sorry, but, comma, singer, comma, is not performing tonight. I'm going to run it, see if I have any syntax errors. Who is your favorite singer? Joan Jett or Huey Lewis? Not JL. Joan Jett. I love rock and roll. Put another dime in the jukebox, baby. Anytime you have if-elses, you need to test all of those options. It's called testing all the paths through the program. So I need to make sure that if I type HL, it does Huey Lewis, and then if I type in something else, then it prints our error message. So I'm going to run it 2 more times and try it out. HL, the heart of rock and roll is still beating. Alrighty, 1 more time. Alrighty, I don't like any of these people. I want Lady Gaga to perform. LG. Sorry, but LG is not performing tonight. Alrighty, so we have an example here of 2 void functions that provide output only, and then a fruitful function that provides input. This fruitful function could actually be improved. There's more than one thing we could do. One is we could make it loop until they type in good input. You know, we could have a list of singers who are acceptable in values, who are on the billing tonight. And if they don't pick one of those, then we keep looping. That'd be a reasonable thing to do. Another thing to do would be to convert what they type to uppercase, so that if they typed in JJ in lowercase, that it wouldn't blow up. All of a sudden I spaced on how to do that. Uno momento. String uppercase Python. Whenever you Google a problem, half the time it takes you to Stack Overflow. Okay, we just do s.upper. So here's what we could do. Singer is equal to singer.upper. I tacked that onto the fave singer. And you know what? You don't even need that singer is equal to singer.upper. Take this part off. Just make it singer.upper. In some languages, you have to actually store it back into itself to get it to work. In this case, we just call singer.upper. It's converted to uppercase. So if I type lowercase stuff, I'm going to type JJ lowercase. It still works. No, it doesn't. Well, let me try it the way I was planning on it. Yeah, Okay, my first hunch was correct. That turns it into uppercase right here. That's kind of like doing a conversion to int or float, except we're not passing it to a function. We're instead invoking a function that is already attached to that variable, which is called a method. In this case, upper is a method because it's a function that's attached to a variable. And we'll learn how to write those, but it won't be until closer to the end of the semester. But you can tell it's a function call, you know. It's got the parentheses and stuff like that. It's just a function call that's following the name of a variable. And we've seen those before. Leo.forward, Leo.left, you know, that kind of thing. So for the people watching the video lecture, I left it paused. Here's what we did. We wrote a square root function that looks like that. You can pause your video and enter that. And then we invoked the square root function down here like this. Let's write a few more. Let's write a function that'll add two numbers. And then let's write a function that will multiply two numbers. Now again, this is kind of superfluous because we could just multiply the numbers right off the bat. But what would happen if we ran this and we typed in a negative number? What is the square root of negative 100? What do you know? Python has built-in support for imaginary values. Imaginary values are numbers that are built around the square root of negative 1. What if we didn't like that? What if we wanted to make it to where if they typed in a value less than 0, all we did is return 0? Maybe that's not a valid square root, but maybe it would be good enough for this code. What we could do is here, before our x is equal to x statement, and I don't even know if I want y'all to type this, but let's go ahead and do it. If x is less than 0, we don't need the parentheses. Then print negative values not allowed, returning 0. And then x is equal to 0, just so that we have something to return. Else, we're going to have to unindent to get our else in the right place, and then tab that over. So this is the code that we added from there to there. And then we had to tab this line over. So add that, add that, add that. Add that, and then make sure we tab that one over. All right, let's try it out. Please enter a number. First, I'm going to test out a good value. Make sure I haven't broken the code. You wouldn't believe how common that is. You try to fix a problem, and you wind up breaking it. Sounds dumb, but that's just honest. That's what happens. As things get more complex, it becomes more difficult to make changes to them without having unexpected side effects. Please enter a value, negative 100. The square root of negative 100 is 0. While that's not mathematically accurate, maybe our program required it in order to not crash, you know. Alrighty. It could be that we should have put this error handling somewhere else. We could have done it right here and not even called the square root function if the value was negative. Or we could have done it here and asked for float. We could have made it an ask for non-negative float function. That would loop until they typed in a non-negative value. You just have to kind of decide where your error handling makes the most sense. All right. Let's do our add function. Define add. Let's call it add x, y. And it takes two numbers in, x and y, colon. Answer is equal to x plus y because we're adding, and a return answer. Let's do the same thing for multiply. Define multiply x, y. Maybe I should have used underscores in there to make them a little bit more readable. Answer is equal to x times y. Return answer. And I may have mentioned this before, but I'm doing this in two steps, and you could actually do it in one. I'm going to modify this to show you the other way. You don't necessarily have to make this change because I'm just going to undo it. You could do this. Multiply x, y. Well, what am I going to return? I'm going to return x times y. That's great. That's great and all that, but it doesn't give you a chance to add any debug print statements or any if logic or whatever. You know, if we had just done return x star star 0.5 here, then it would be harder to debug, to add print statements, to figure out, you know, what x was before we returned it or whatever. So I like this pattern. Calculate the answer, then return it. Don't try to do so much, you know, in one step. Break it down into the smallest steps possible. And then if it makes sense to you, you can combine them. But all right, so I'm going to undo those. Alrighty, I hope the square root function and this input function, this ask for float, are all good because I'm going to scroll past them now. So we don't have two numbers to add or to multiply. Let's ask the user for x, let's ask the user for y, and then let's tell the user what those two numbers added are and those two numbers multiplied are. So let's just use a print statement to tell them what we need. We need an x value. And then we're going to call our input function. X is equal to ask for float. It might be nice if we made this ask for float function accept a string that we could display, kind of like the input function can. Then we wouldn't need that extra print telling them what we want. But our goal is not to make the code as complicated as possible. Let's leave it as is. Now let's ask them for the y value. Print, we need a y value. Suddenly it occurs to me to wonder why the English language uses and for things that start with a vowel and a for things that don't. Why? How many other languages do something like that based on the first vowel of the following word? Anyways, y is equal to ask for float. Now let's print our answers. Well, we actually have to call these functions. Answer is equal to add xy, parentheses x times y. Answer is equal to multiply xy, x times y. You're right, I do need to do two different ones unless I just print them out as I calculate them. So let's do answer 1 is equal to add xy, answer 2 is equal to multiply xy. That's an incredibly good point. And why? Because if you just keep calling these functions and storing them in the same value, then we're overriding that value. We'll never know what add xy was. Now we could kind of fix that by putting some print statements, you know, between these calls that work. Alrighty, now to print our output. X times y equals colon answer 1. Print. I don't know why I did x times y first. That's actually add x plus y. X plus y is equal to answer 1. X times y is equal to, quote, comma, answer 2. All right, that seemed to work. So we are going to do a homework assignment based on this idea. You know, I'll make the due date spaced out so that, you know, we don't have more than one assignment due on the same date. But here's what it's going to be. Let me pop up another document so I don't have to scroll this off the screen. Take our mfunc code and add support for the following math operations. Divide, subtract, power of, and modulus. So what's that really going to take? It's just going to require 4 more functions. Divide xy, subtract xy, power of xy, modulus xy, and then it's going to require, you know, some invocations of those functions. So that shouldn't be too hard. I will upload that. Let's make a Dropbox for this, but one last thing we need to mention is how to flowchart one of these functions, or any function. Let's take care of the Dropbox first. Oh, I didn't assign a due date for the house cost. Clever me. All right, then it's due next Sunday. I never feel it's fair to suddenly assign a due date, you know, and then you just find out, oh, that's due tomorrow? It didn't have a due date. I didn't know. All right, so Alright, so there is a Dropbox J, in case you need to walk out. I'm going to go to Lucid Chart. Wouldn't be a bad idea for you to follow along, but we're going to cover this more carefully on Wednesday. Really? There. Okay, so we had 2 really important functions besides the square root one. we had what I'm going to call the main code, but I'm just going to call it start. We also had a add xy function. So I'm putting that one in a circle, and we had a multiply xy function, which I'm putting in another circle. Oh, and we had our input function, excuse me. I should have just called it input float rather than ask for float, but anyways. All right, so we really have ask for float. If you want to put the word DEF in these functions, just to remind yourself that they are functions, that's okay, not necessary. But you had better list the parameters. Ask for float didn't take any parameters, so I'm just putting parentheses there. Add xy did take parameters, so I'm going to put x comma y inside parentheses. Define mult xy took parameters. All right, now whenever we call one of these function calls, I think our Word documents showed using a box with horizontal lines along the top and the bottom. Well, we don't even have that symbol, and we're going to use this one, the rectangle with the vertical lines. X is equal to ask for float. I'm just copying and pasting to make it easier to type. Y is equal to ask for float. I'm skipping some print statements, you know. Kind of like in our pseudocode, we didn't say please enter age, we just did input X. What this box with the vertical bars means is that this just isn't a process. It's just not a math or anything like that. It's actually a function. It's going to call one of these other functions that we're defining. So before we go much further, let's go ahead and finish the ask for float function. And what it does is it printed a message. So I'm going to use an input-output box. Print, enter a number. Then it input that number. Input X, or X is equal to input parentheses in parentheses. Either one would be okay. Then we had some math, convert X to float, or X equals float X. Either would be fine. And then it's a fruitful function, so we need to return X. The return is another oval. Alrighty. Add xy. That's going to be an easy one. It only had 2 steps. One was a math calculation, so math happens in a rectangle. Answer equals x times y. And then we had a return statement. Returns are in the ovals. Return answer. That's a funny looking add, isn't it? I keep getting stuck on multiplication. Answer is equal to x plus y. Multiply is the same exact thing except with that multiplication that I wanted in the first place. Answer is equal to x times y. Return answer. All right, we've called the define ask for float function, but we haven't called add or multiply. So I'm going to go back to my main code under the start box. And this one's going to be answer1 is equal to add xy, parentheses, x comma y. Except that should have been a function call box. So I'm going to right click on it, do change shape, and pick the rectangle with bars. Now I need to calculate answer 2. Same thing. It's a process. It's a function call. So I'm going to use the predefined process block, rectangle with vertical bars. Answer 2 is equal to add, multiply x comma y. And I'm not going to make my print statements real complicated. I'm just going to do an output answer 1 and then an output answer 2. Print or output. I'll just go with print, whichever. Print answer 1 and then another one of those that says print answer 2. And although it should be beneath it, I'm going to put my final stop block off to the right, just so I don't have to do any scrolling or reducing of the size. You certainly don't need to do that. All right, that is a done flowchart. One thing I like to do, if I can, if it makes sense, is just to color code these things. And what do I mean by that? I'm going to give each one of these ovals a slightly different color. This is absolutely not necessary. But the first one, I'm going to use that paint bucket to fill it with a yellow. The second one, I'm going to use the paint bucket to fill with a pale blue. And the third one, I'm going to use the paint bucket to fill with a pink. Then I'm going to color code the function calls to match. These are ask for float. They both call the yellow one. I'm just going to select them both and go up to paint bucket and pick yellow again. Add is blue, so I'm going to select the add call, change it to blue. If you're writing a complex program with hundreds of functions, this is a ridiculous idea. But for a beginning class, for learning fundamentals, I don't think it's a bad idea. There we go. Why do that? Because it makes it instantly obvious what is calling what, you know. And functions can call functions. You could have add xy, run a loop, and that loop did the multiplication, you know, because if you're going to add, if you're going to multiply 3 by 4, what you're doing is you're adding 3, 4 times in a row, whatever, you know. So the color coding for logic like this can help you eyeball it, but it's not necessary. All right, if you did this, that's totally cool. We're going to do another one on Wednesday. I believe Wednesday should be our review. I think we've already talked about the exam. It's going to be open book, open PowerPoint, open notes, open any of your assignments you've done in the past, open your teacher. Well, not realistically. I mean, that'd be kind of gross. But, you know, raise your hand and I'll come help. So don't stress over it overly much. Just do a download as if you did this. Since I didn't give it a good name, it's just called blank diagram. I'm going to do a save as and give it a better name. mfunc. And then file download as PDF, and now I have a better file name to upload. Alright, this last assignment really is pretty easy. We already have the template for the functions. However, I don't want to load up too much work right as we're getting towards the end of the semester. Not the end of the semester, but before spring break. So if I'm correct, spring break is the week after next. So we'll make this due the Sunday of spring break. Not to be a jerk, but really you ought to be able to finish this in an hour. So that's way too much time. You don't have to do a flow chart for this assignment or pseudocode.